figure out, how can you determine if the, like, by looking at the graph, if the lead coefficient is negative or positive?
Okay, so, right here, let's talk about a couple of details. And I would update my notes to my future forgetful self based on this conversation. So, I want us to recognize this. How many different types of degrees do we have?
A lot.
What you trying to say, like,
Types of degrees.
one.
What you mean types of degrees?
Types of degrees. Think about what you just saw in Mathia, right? Well, so there is first degree, there is second degree, there is third degree, there's fourth degree, but I can group those together. I can group first, third, say it again. Odd and even, right? Every odd degree polynomial had what type of end behavior? The end behavior was different. It was the opposites, right? Whereas we also have even degree, where the end behaviors are the same, okay? So what's the other thing, though, that determined the end behavior?
The point. America points the end.
So what? That's the degree, right? So let's say this. Say it again. Which coefficient? So what's that? What coefficient is that? It's the coefficient with the term with the highest degree. So it is the leading coefficient, right? So there's my leading coefficient. So that also determined what the end behavior would be, yeah?
Yeah.
Okay, so it's whether the leading coefficient is what or what? Positive or negative. All right. So we already said odd degree, it's opposite end behaviors. And if it's even degree, it's the same. And so if it's positive and it's odd degree, what's it going to do overall? It's going to, say it again. So this would have a positive positive leading coefficient. So that's the idea of decreasing. Notice that's similar to a slope being negative. Notice I always do my odd degrees, I go back to a line. Hey, y'all, eyes and ears here. We cannot learn if eyes and ears are not here. I know you want to complete an assignment. I want you to learn and then complete the assignment. So, opposite end behaviors, but it's positive, so it would look like this. Whether it's third degree, fifth degree, first degree, right? So, if I see this, I don't remember, was that counsel or Deb? It was counsel asking this question, right?
Yeah.
So counsel, if I see opposite end behaviors and it's increasing overall, I know it's odd degree with a positive leading coefficient. Make sense? Okay?
Hold up. So you're basically looking on the x side.
Say again.
You're basically looking on the x to see like if it's positive or negative.
If what's positive or negative?
On end behavior.
So I'm looking at the leading coefficient, right?
What's your leading coefficient?
In this case, what would my leading coefficient be?
3.
3. And it's odd degree, so I know the end behaviors are opposite, and I know it's positive, so it's overall increasing when I think about the end behavior. That's it. Right? So if it's negative, right? So notice we also need to pay attention to stuff like this. Would this be odd or even degree polynomial? Why do you think it's odd? So Cam, just so it's a little bit closer to you.
3 is 3.
Is it 3?
It's negative.
No, it's 6.
It's 6. The degree here is 6. Why?
Multiply.
We're multiplying. So this is not standard form. This is what?
Exponential.
Form.
13.
Form. Hey, come on, y'all. What are we doing here? We're
Factor.
multiplying. So it is factored form. If it's in factored form, there's two things to think about. How many zeros are right here in this factor?
I can't see.
If it's x cubed, it is 3. How many zeros are in this factor? 3. Right? X cubed. And so if I have 3 zeros here and 3 zeros here, it has to be what degree? It has to be 6 degree. If I were to distribute negative 3x to the 6th, minus 21x cubed, right? So we have to think about it in standard form to know how many zeros and what degree it is, okay? But this is an example, right? So odd degree, so in behaviors are what, Simone? Odd degree, so the in behaviors are what? Are they the same or are they opposite? They're opposite, right? There we go. And if it is negative, Julian, is it overall increasing or overall decreasing?
Decrease.
It's overall decreasing. Just like a line with a negative slope. Boom. I don't know honestly about the middle, I'm just making that up, but I know what the in behaviors are.
Yeah.
Okay? Even degree. What's gonna, and the leading coefficient's positive.
Same.
The same, and they're gonna go up. Doesn't matter how complicated it is, notice that's wicked complicated. That's still even degree and up. Okay. So there we go. Now, Denasia, Mason, Trey, I need y'all to look at this. Any predictions what degree this polynomial would be right here? Not just even or odd, but what degree could this one be?
6.
3.
5.
Man, see, I didn't realize y'all's names was Denasia or Mason.
Oh.
You were thinking what, Denasia? 4. Mason, do you agree?
I was gonna go 4.
You're going to go 4th as well? So what's your reasoning behind that?
The turns.
The number of turns, okay? So what about those turns?
Yeah, it's always one less, or it's always one above, because like if you do 3, then it's gonna be to the 4.
Oh wait, so say that again. You said if the number of turns was 3, the degree would be 4. So how many turns do we have here?
3. Wow.
We have 3 minima, right? But we have how many max?
2.
2. So that would be how many turns? 5. So it has to be degree,
6.
it has to be at least degree 6. So you're on the right path, right? Notice the number of extrema is the degree minus 1. So if the number of extrema is 5, what does n have to be? 6. And I will say this, it has to be at least 6. Because those extrema come in pairs, right? So the degree could be higher than 6. Last couple of details before we get into today's newish concepts. Does anyone know, I'm going to leave this out there, I need Eisenhower's, Jaden. Does anyone know how many real and how many imaginary zeros, or what the multiplicities of the zeros would be for this one right here?
No, sir.
Won't all of them be imaginary 0?
What do y'all think? Anybody want to push back or add on to all of them being imaginary?
I think counts
Well,
right.
except for the,
Real.
I mean,
The
the
rest will be
line going
imaginary.
through it, but like ain't none of the.
Wait, you just said the line's going through it, right? These zeros would be what?
Real.
How many real zeros do I have?
2.
So I have to have how many imaginary?
Wait, let's go.
3.
Say again, Dewan?
Huh?
How many did you say?
4.
4. 1, 4.
What? How many zeros do we have to have if it's 6
Oh,
degrees?
6.
We have to have 6, right?
You're right.
Do any of these have multiplicities?
No.
It goes straight through, right? There's no curve through it, it doesn't bounce, there's no multiplicity, so I got 2 real, those other 4 have to be imaginary.
I do this.
Facts.
But I don't-
Alright, making sense out of these things?
Little bit,
Little bit, okay. So let's continue today.
They do.
Or not.
Um,
I didn't understand all these numbers, bro.
Or
so-
we can not continue.
remind me, Dewan, when is this assignment due if you haven't finished yet?
Oh, before class Thursday.
Before class Thursday, thanks, sir. So really quickly, I'm missing something. There we go, test reminders. I have forgotten to bring this up, so I haven't put the zeros in, but I'm gonna have to look soon and, like today, and put zeros in for tests if they have not been made up. There's one student I will not put a 0 in for yet, but he and I have been working together, so I know he's working to get better. Sorry, I've been meaning to give that to you. You're gone when I got it. Huh?
What test we talk about?
The solving quadratic equations test from like 2 to 3 weeks ago. There are still several people who have not done it. I'm here to help you be successful, huh?
Can you tell us?
I will check in a minute, but we already did our recap of the gallery walk activity. Please hear me clearly on this. We have got to master these concepts, right? There's a few major ideas. That's what the Mathia is about. That's what this instruction was about. Make sure that you are actively trying to learn it because you are all capable of learning it. Y'all are sharing ideas that are correct, right, Julian? But we gotta make sure we fine tune it, that we practice it. So here's what we need to do. I believe Mr. Arliss already had you tear this lesson out of the book. Actually, so two things. Proficiency scales. I need you to stop where you are on the computer, log out. So let's do that first. Log out. Put the MacBooks back with plugging them in so they are ready for third block.
Okay, so bring your baby in.
Great. MacBook's back. Dewan, leave that computer there, but come move to a different room for me, okay?
I'm sitting in my group.
Okay.
Guys,
Guys,
Mr. Kenny, do it automatically save, right?
laptop's up.
we'll get my okay.
It will automatically save.
Alright, there you go, my dog.
There you go, mama. Pull these up. There you go, Spencer. Hand me that, Sergeant. Y'all hold. You back? Hand back your back. I hope y'all go back. Be quiet your back.
Oh,
Your back too. That was your back.
you said what you already had this?
Yes, let me go look, see what pages it is. What you confused by?
I pass you a knuckleball, like.
M1-227.
Is it a polynomial?
Yeah. Name is Polylog or something like that. So, hey guys, the pages you should have torn out start on M1-227 through the end of the lesson.
I don't think we drew that out.
I don't know about them.
Mr. Arliss had asked you to do it yesterday or 2 days ago. So maybe Friday. Yeah, Polywog, hold it up for us. That, it looks like that one. And I need proficiency scales out.
Put that phone down. Put that phone down right now.
Y'all
Kid is looking so fast. Put that phone down right now. Oh, I gotta get my way.
227 through what?
through the end of that lesson. So it should be page 227 through the end of that lesson. Huh? M1-227 through the end of that lesson. Go on. I will collect these if I need to. Put them away. Put them away.
Dude, you look at it.
He said 227.
Is it gonna help you focus?
What's the end of that lesson?
There you go. All the way there.
Your foot finna fall through the bottom.
It's 225.
Yeah, no comfort.
I'm gonna drink a bit. You laughing?
M1-227. 225.
All I got is right here.
Okay, then let's get it.
I ain't even got no bull. Oh, that was my bull.
You gonna get booked when we got home,
Is it the sketch of polynomials?
Say again.
Polynomials, is that the?
Yeah, the sketch of polynomials. I actually need to get print another one. I thought Mr. Arliss
I got it, yeah, I got
Because I was at my house.
225 to 248 is what we should be tearing out.
20 pages.
Where's your textbook? You need to get your stuff and bring it. We need to practice. So it looks like you already tore this out.
We ain't volume this late. We ain't volume.
Well, you need your binder too. You should have already torn it out, or I thought y'all had. Say again. Okay, so you got the other pages in your. Tear out the rest of the lesson. I told you multiple times.
It's 225 to 248.
You just got me the head.
225 to 248.
You can't have my name. And then he did say, I do work at Dairy Queen. You think you work at Dairy Queen, you can't hurt my feelings, though. You said you can hurt my feelings.
Hey guys, we ready? We got our stuff torn out? Bring your book. Go look to see if it's in any of those volume 1s up there. Actually, dude, there's a million volume 1s because none of y'all bring your stuff. Look in one of the volume 1s near you.
What council know about it? What you talking about? Oh, what page you talking about? You get no most. If you're gonna be able to read it. You got no most. I got all the most. You got no. You did?
Alright. Most of us have these pages torn out. If you have not yet, keep doing it. But I did just notice that Mr. Arliss did not print out one of the proficiency scales that I thought he had. I will get that to y'all tomorrow. But I just want to point this out because these are the things that we need to be able to do in the target range. Actually, let's start in the foundation. It's hard to hit target if we can't do foundation. So, can we start to identify the degree of a polynomial just based on the shape of the graph? Or should we be able to? Yes. If we don't know how to, that means come into tutoring, ask questions, right? But we should know how to do it. Yes. Say that one more time. I believe, or is it analyzing?
No, we define the analyze.
We're on defining and analyzing. I'm sorry for lying to you. That's a thing.
Why are you always lying?
No, there's multiple copies over here.
Oh.
Multiple copies right there. All right.
You said we on sketching?
Defining and analyzing. Sorry. Can we identify the domain, range, and intercepts of a polynomial? We might still need to work on that. Notice that is, hey guys, there's a reason why that is foundation. That is actually a really important Algebra 1 skill that we should have learned last year. If we're not there yet, we do have some practice coming up that'll help us with it. But we do need to know domain and range, okay? Kyson, what's the first thing you should think of when you hear the word domain? Close. Not x-intercepts though. X values, right? And the x-axis tells us what the x values are, but it's x values. Or what's another word for those x values? Starts with an I.
Intercept.
It's not intercepts, not integers, could be decimals.
Artificial.
It is INP.
Interpret.
Not interpret. INP. I think someone said it.
Empirical.
Golly, guys. X values are the what for our functions? They are our
Inputs.
inputs. Okay. So remember, X values, my inputs. If I'm looking at a graph, I'm looking from the what to the what?
Left to right.
Left to the right. Minimum to maximum. And so if I'm talking about range, right? Which type of values are those?
Outputs.
Y values or
Outputs.
outputs. There we go. And so that means I'm looking from the.
Top to top. Bottom to top.
It's always minimum.
So we keep these texts, or we gonna give them back?
You can keep them.
I know you had.
So after the semester's over, you can trash them. Hey, council, Dewan, guys in this group, people are trying to do notes to your future forgetful self, so we're going to be respectful to that time, and we're not going to talk. Is that clear?
I need a pencil. Please.
Dog, we are 75 minutes into a 90-minute class, and you're asking for a
Hey, can I
pencil?
get my iPad or my stuff that way I don't forget it?
Yeah, I need it back, Dewan.
Just bring it back, I'm gonna forget it.
Yeah, I understand.
It was.
What we doing there?
They don't even have a book. Y'all be having a pencil.
I know for like
I need that.
All you do is grab the ball.
Council, what did I just ask? I know there's other people talking. I'm about to go talk to them.
I wouldn't even think that.
Someone for pages out. That's fine. But that's not all of it. Because look, 28, 29. Oh, I lied. That is all I Okay. So, with all those things that we have talked about at this point, right? If you need to continue taking some notes, do that. I'm going to do a quick note here. So, Denasia, about to look at this ugly equation, but it's not bad. What do you know about this function right away? Alright, so we've got fourth degree. Dewan, what do we know? What else do we know about this polynomial beyond it being fourth degree?
You said what else do we know about the
Yeah.
polynomial?
Yeah.
What you call it? The leading coefficient.
The leading coefficient's what?
0.2319.
Alright, but we need to start putting this stuff together, right? I agree, fourth degree leading coefficient 0.2319. But Yana, what does that tell us about this polynomial?
It's a quartic.
Okay, quartic is the name of it. But one, Yana. Two, I want you to start thinking about the graph of this. What do we know about the graph of this polynomial based on the fact that it's fourth degree and the leading coefficient is 0.2319?
The starting point.
Yana.
I would just tell you.
I know, I said Yana. Yana, give me one thing. Not everything, just one. Say again.
The y.
Okay, so what's the y-intercept? It's what? 10,604? Does anybody want to add on to or push back on that?
No.
0 in the front, because the x value is always 0.
Yeah, third.
Dewan, or not Dewan, Julian, why in the world did Yana think that 10,604 is my y-intercept?
Because it's on the right side.
No, it's not just because it's on the right side, there's something else.
I mean, technically, he's not wrong.
Oh, it's not just because it's the last
It
number.
look like standard form.
Yeah.
It is standard for, alright, so what if I had this?
I mean, technically, he's not wrong. That's what I'm saying.
But technically, if that's the only way he sees it, then he will get it wrong in the future.
Exactly.
So I want you to learn well, not just small tricks. What would be the y-intercept of this function?
The second.
B.
No,
Whoa.
it's still C.
No, we got an X on it.
No, it ain't got it.
It's still the same.
Tell me the number. So it's the same number still?
Yeah.
So it's not just what's furthest to the right, is
So
it?
they got an X.
It ain't, it's by itself.
It's not just
No,
that. Hey, Julian, what do we know about every x-intercept that's, or every y-intercept that's ever existed?
X.
The x is what?
The M&M's is mine.
X is what?
It goes up and down.
No. Say it again.
Come on, Julie.
What'd she say?
0.
The x is 0.
My
Remember, if it's a, no, you're good. This is a learning opportunity. If it's on the y-axis, the x is always going to be 0. So if x is 0, what does this whole thing become? 0, okay? There's no x here, so this stays as 10,604. What does this become since there's an x here?
0.
So it's not about just being furthest to the right, it's about the fact that if x is 0, everything else becomes 0. And then you get 10,604. Does that make sense? And you're not the only one who had that question, I promise you. Make sure you ask it. Okay,
Thank you, Julie.
I got a question about the email.
say again.
I got a question about the emails right there.
The answer is no. Alright guys, come on.
Can we get some of the
No!
If we get it right, Eminem.
I'll pray about it.
Come on. Miss women.
Only if I toss it and you catch it in your mouth. If you don't catch it in your mouth, you got
She's tweaking.
right here. Eyes and ears. Listen, guys, you are clearly forgetting the entire mathy assignment you just did.
Yeah.
What else do we know about this polynomial?
The NBA.
Thank you!
I said that.
No, you didn't!
Earlier.
I was
Okay.
saying, but you
So-
were talking
That
about.
was a math.
You
No,
said
I asked, what do we know about the graph of this polynomial? What would the end behavior of this polynomial look like?
Opposite. I mean,
Yeah,
it's gonna be the same. It's gonna be the same.
If it's
I was gonna
even,
be
If it's even, it's gonna be the same. Same
Okay.
direction.
you think it's gonna be down?
Oh.
It's gonna be the same.
It's gonna be up though, 'cause it's gonna be up.
It's
Okay.
gonna be popular.
No, it's not.
KK, we got a lot of conversation here. I need you involved
It's
though.
gonna be up.
Okay, hold on. So KK, we got first people were saying the same or different. Which one do you think it is, KK? You think this is the same?
Yeah.
Okay, why is it gonna be the same?
Wait, what's the number?
Let me say again. Okay, not just first number. Listen, we got to remember this. Kyson, what is the most basic even degree polynomial we have ever studied? The very first one.
2.
X squared, right?
Yeah.
And if it's x squared, if we think about that parabola, it's always going the same, right? Up or down. Okay? It's always going the same. And so, fourth degree, it's even. It's going in the same direction.
That's why cubic look like that.
Uh-huh. Because it's cubic is odd, it goes opposite. So this one, the leading coefficient, is it positive or negative?
Positive.
So it's going to be going up. So I know that the ends are going to look like this. Come on, what else have we learned?
Nothing.
That's not true.
Nah, I'm smart as you, right?
You were good. Down on the ground.
Why did I do 4 minus 1 equals 3?
All the time.
Ah, the number of, say it again, Denasia. The number of extrema, right?
Yeah.
The maximum number is,
The hive.
maximum number is
The 4.
You take my.
Not 4.
3.
3.
3. Remember, n minus 1 is the maximum number of extrema, right? And so that is the maximum. It could be 3 or it could be
1.
1, okay? So more than likely it's going to be something like this,
Go back in. Go back out.
more than likely. Is there anything else we know about this quartic?
The
You're forgetting like the most fundamental thing.
Is the 5 degree called degree?
Quintic. Say it again.
The root.
The roots.
Oh.
Literally, there's something called the fundamental root. Starts with a T.
theorem of algebra.
Theorem of algebra. The fourth degree is going to have how many roots?
4.
4. And so it could have 4 extrema. Alright. So it might look something like this. Alright. Listen, hey, this is what you need to start doing is when you look at that equation, you need to be able to think through how many extrema are there, how many x-intercepts could there be, and picture, in the end behavior, picture what it could look like.
Got you.
So let's look at this. This is out of the pages you just tore out of the book. I don't know, does that look pretty similar to what we just said?
Something like that.
Something like that, right?
Holy moly.
Oh, kind of skewed right.
Kind of skewed right, I like that language, but notice, I want you to hear me clearly on this, right? This is what you are capable of. Now, you don't have to know exactly what it is, but you do need to be able to make a prediction. How many extremas is it going to have? What's the end behavior looking like? How many x-intercepts could it have?
Yes, sir.
Call.
So, here's one thing I want you to do. It asks about domain and range of the function in this problem. But I will point this out, and we're going to skip the rest of it because I just want to focus on B, domain and range. Kyson, remind me, what do we mean by domain?
Oh, I remember.
All of the what?
All of the values.
Which values?
The x ones.
There you go, right? Horizontal x values, right? So I want y'all to think about in your small group all the x values. Now, I want us to also then talk about the range, which, Des, what do we need for range? Range? What is rise divided by run, Des? That's my what? That's my slope. What do I need for range?
Nothing.
I need my y values. Now I need to point this out.
Ain't nothing.
Does anyone know what we would need to find in order to know my y values for this function? There's one thing I have to find.
Yeah, why intercept?
Maximum, minimum.
My maximum and my minimum. Specifically because this goes up for forever, I need to know the what?
Minimum.
Minimum. Notice, is there an absolute minimum that's the lowest for the entire graph?
Mr. Kimbrough at the door.
I know.
No.
Yes, there definitely is. Come here. Jaden, put a point at my absolute minimum over here.
I can do it real quick.
I do it.
Let me do it.
I'm going to go back to you tomorrow.
I do it.
Run up here, let's see it.
I'll never do nothing.
Yeah, don't do nothing.
I never do
Why are you scared? Come on, Des, hurry, let's go. Come on. I know you just woke up, but let's go. Absolute minimum. Alright. Anybody want to add on to or push back on that absolute minimum?
You said minimum.
Yes.
That's maximum.
That's
Hey, big bro,
maximum.
that maximum.
You
I
said
said minimum.
Hey,
Absolute minimum.
first off, hey, hold on. Okay, hold on. Don't erase it. I want to talk about it in a second, so hold on. Council, you had your hand up first this time around, so come on, Council. I said this time around. Chill. There we go.
I'm finna take my hand.
I know. Alright, so, hey,
Maximum though.
last couple of details. I need y'all to hear me on this, right here. First off, is this a maximum? Maximum.
That's not a minimum.
Oh, say it again. It's relative. It's not absolute. Why is it not absolute?
Because
it keeps.
Notice, this continues up for forever. So are there y values higher than this one?
Yes.
Yeah.
So if there are y values higher, that's not an absolute, but it is a relative maximum. Okay. Why is this an absolute minimum?
Because that's where it starts.
That's where
It don't go down.
It don't go down
the
no
lower
more.
point. It don't go
Okay.
down.
It never goes below that point. So here's what I need you, actually for the sake of time, we only have 3 minutes. First off, just 30 seconds in your small group, think about what the domain is. Just 30 seconds in your small group, what do you think the domain is?
Domain is a range.
Hey, talk to your small group. I said 30 seconds. It's in the textbook. Pages you just tore out, it's all right here. Jaden's working smarter, not harder. Even from there? Textbook page, right? So we need to have been talking, right? So let's see here. KK, what did y'all come up with for the domain on this one? Negative infinity to infinity. Anybody want to add on to or push back?
No.
Okay, so no one wants to push back. Can anyone explain why? Add on to why it is negative infinity to infinity. Keep going to the
Negative. It goes to the left and to the right.
Okay, that arrow means it's going to continue going.
Left.
And it's going to keep going.
Right.
So that's my minimum x. And
And
this
my
is
maximum
my
x.
Hey, right here. I need eyes and ears on this. You see how I gave evidence for my claim that the domain is negative infinity to infinity? What do I want to see on assessments? I want to see understanding. Is that evidence of understanding? Could I do more? Sure, but that's enough. Okay.
He
Hey,
said, that boy said give him a demonstrated understanding tomorrow.
good, I will. All right. Just kidding. I'm kidding. Hey, pause. I got 60 seconds. Range. What do I need for my range? Okay, do I know my minimum y?
Yeah.
Do I?
The one sit your
What is it? Guys, hey,
Hey.
I got 60 seconds. I need you to pay attention. Last 60 seconds.
It's your minimum right there, your own.
But do I know what this y value is?
No,
I don't. Now, do I know what the maximum is? Infinity, right? Never quits going up.
So you put
So,
Y.
I'm going to find out what that y is. That's what we're going to start tomorrow. But notice it's an absolute minimum. Why did I put a bracket here instead of parentheses? It's going to be a real point on the graph. It's a value that we actually have. Alright, so what is due Thursday? Before class Thursday? Carnegie Learning Assignment. Now, hey guys, do you have to finish the entire unit?
No.
Just the first two workspaces. The first two workspaces.